can see here, we have focusing.
We saw a variety of Chladni patterns at a variety of frequencies. As predicted by theoretical analysis, higher frequencies resulted in more complex patterns. We saw differences in the duration and movement of different types of particles as with the microscale, where tumor and red blood cells act differently. We tested mung beans, salt, sugar, and silicon beads of different sizes focused at different rates. Powdered sugar showed antinode focusing as a result of its small size. We did not expect this to occur successfully, however it did. We also measured frequencies where we saw focusing and compared those values to the complexity of focused shapes. We recorded and compared particle sizes and densities. We compared the time it took for different particles to focus, and we compared the focusing patterns of different particles. We came up with a variety of performance specifications desirable for a finalized prototype or blood filtration device. However, only several of them apply in the context of this project with the resources at hand. For example, we cannot measure an exact value for efficiency of filtration, but we can observe focusing and qualitatively discover which configuration produces ideal focusing, if at all. Our performance specifications were as follows. Focusing down the midline of the pillars in our microfluidic channel indicates successful performance. We saw this in the microfluidic channels we fabricated and tested. Although this was not a strict requirement or expectation, we hope to see focusing of beads at a flow rate rather than just in static fluid. This was successful. We were able to pump a syringe to create flow and capture beads in the channel as they flowed by. Note that a requirement for a final prototype would be a high flow rate. However, in the context of this class and the resources available, our performance specification is to see any flow rate at all with combined focusing. We did in fact find that this was the case. Both the ANSYS and microscale device showed best focusing at 75-degree angle. Overall, the microfluidic device showed a significant amount of success as compared to expectations. If we show best focusing in the same frequency and angle as predicted in ANSYS analysis, that confirms that the analysis accurately represents the physical design.